Hello everyone, welcome to my channel. Myself Dr. Munsifa Firdaus Khan Barbhaiya. In this video, I am going to explain sorting algorithms in data structures. Watch the video till the end everyone. Thank you. These are the contents that we are going to learn in this video. First is bubble sort, its working and example. Next is selection sort, its working and then example. And finally, insertion sort, its working and example. Now let us understand what is a bubble sort. Bubble sort is also known as exchange sort. It is a simple sorting algorithm. It works by repeatedly stepping throughout the list to be sorted. That means comparing two items at a time and swapping them if they are in wrong order. It is the easiest method among all sorting algorithms. In bubble sort, for n number of elements, n minus passes are required. That means if we are having a list of 4, 5, 6, 7, that means here the number of elements is n is equals to 4, then the passes it will require is n minus 1, that is 3 passes it will require to sort this set of elements. Bubble sort is a stable algorithm. That means a sorting algorithm is said to be stable if two objects with equal keys appear in the same order in output as they appear in input. Next is the space complexity of the bubble sort. As we know that space complexity of an algorithm represents the amount of memory space needed by the algorithm in its life cycle. So in bubble sort the space complexity is order of 1. And next is the time complexity. We know that time complexity of an algorithm is the representation of the amount of time required by the algorithm to execute the completion. So the best case, we know that in time complexity there are three cases: best case, average case and worst case. So the best case for bubble sort is order of n, the average case is order of n square, and the worst case is order of n square, and where n represents the number of elements. The next topic is working of bubble sort. So the bubble sort starts with the very first index and makes it as the bubble element. The first index as the bubble element and then compares the bubble element with the next element. If the bubble element, that is the first element, is greater than the second element, then both of them will swap. Otherwise there will be no swapping. After swapping, the second element will become the bubble element. That is, the second element will become the bubble element, and now we will compare the second element with the third element as we did in the earlier step, that is in the step 1 as we did. So the same step will be followed, and if the second element is greater than the third element, then there will be swapping. Otherwise there will be no swapping will be done, and the same process is followed until the last element. And for each iteration, the bubble sort will compare up to the last unsorted elements. And once all the elements get sorted in ascending order, the algorithm will be terminated. Now let us take an example to understand bubble sort. So in this example we have taken 17, 16, 40, 34 and 15. There is 5 elements we have taken. As we know that the number of elements, if n is the number of elements, then n minus 1 is, that is 4 is the number of passes. That means 4 passes will be required to sort the elements. So for pass 1, the input is 17, 16, 40, 34 and 15. Now we know that the first element is the bubble element, and we will compare the first element with the next element. So we know that 17 is greater than 16, so there will be an interchange. 16, 17, 40, 34 and 15. Now 17 is the next bubble element, it will be compared with 40, so 17 is smaller than 40, so no interchange. Now 40 is the next bubble element and it will be compared with 34. Now 40 is greater than 34, so there will be an interchange. So 16, 17, 34, 40 and 15. Now finally 40 is the next bubble element and it will be compared with 15. 40 is greater than 15, so there will be an interchange. 16, 17, 34, 15 and finally 40. So our pass 1 is finished here. Now let's move on to pass 2. So the input of pass 2 is the output of pass 1, that is 16, 17, 34, 15 and 40. Now let us start with the first element, and which is the bubble element, and we are going to compare the 16 with 17, and we know that 16 is less than 17, so there is no swapping. Now 17 is the second bubble element and it will be compared with 34, that is the third element, which is also less than 34, that is no swapping. Now 34 is the next bubble element and it will be compared with 15. Now 34 is greater than 15, so swapping will be done. So 16, 17, 15, 34 and 40. Now the fourth bubble element is 34 and 34 is less than 40, so no swapping will be done. Now let's move on to pass 3. Now the output of pass 2 is the input of pass 3, that is 16, 17, 15, 34 and 40. Now 16 is the first element, it will be compared with 17, so no swapping will be done since 16 is less than 17. Same goes to 17 is the next bubble element, it will be compared with 15. Now 17 is greater than 15, so swapping will be done, that is 16, 15, 17, 34 and 40. Now the next bubble element is 17. 17 is less than 34, so no swapping will be done, and 34 is the next bubble element which is less than 40, so no swapping will be done. Now let's move on to pass 4. Now the output of pass 3 is the input of pass 4, that is 16, 15, 17, 34 and 40. Now the first bubble element in 16, and 16 is compared to the second element, that which is 15, that is 16 is greater than 15, so swapping is done. 15, 16, 17, 34 and 40. Now the next bubble element in 16, 16 is less than 17, so no swapping is done. Now next bubble element is 17, 17 is less than 34, no swapping is done. 34 is less than 40, so no swapping is done. That means the sorted list is 15, 16, 17, 34 and 40. So this is the final sorted element. So we have achieved it after having pass 4. Now the next topic is selection sort. In selection sort, the smallest value among the unsorted elements of the array is selected in every pass and inserted to its appropriate position into the array. It is also the simplest algorithm. It is an in-place comparison sorting algorithm. It is also a stable algorithm like bubble sort, and the space complexity is also similar with bubble sort, that is order of 1, and the time complexity, the best case is order of n square, worst case, average case is also order of n square, and worst case is also order of n square. Now the next topic is working of selection sort. In the selection sort, first of all we set the initial element as minimum. The initial element will be set as minimum, and now we will compare the minimum with the second element. We will compare the minimum with the second element, and if the second element turns out to be smaller than the minimum, then we will swap them, followed by assigning to a minimum to the third element. Else if the second element is greater than the minimum, which is our first element, then we will do nothing and move on to the third element and then compare it with the minimum, and we will repeat this process until we reach the last element. And after the completion of each iteration, we will notice that our minimum has reached the start of the unsorted list, and we will repeat these steps until the list is sorted. Let us consider an example to understand selection sort. So the same example we have taken that we earlier took in case of bubble sort, that is 17, 16, 40, 34 and 15. So 17, 16, 40, 34 and 15. In the first iteration, we are going to set 17 as the minimum element. So now we are going to compare 17 with 16. Now since we know that 17 is greater than 16, now 16 will be the next minimum element. Now we are going to compare 16 with 40. We know that 16 is less than 40, so fine, 16 will remain same. Now 16 will compare with 34. We know that 16 is less than 34, it will remain same. Now 16 will be compared with 15. We know that 16 is greater than 15, so we are going to set 15 as the minimum element. So we have found in this list 15 is the minimum element, so we are going to interchange 15 with 17, that is in the first position, that is 15, 16, 40, 34 and 15. Because in the first iteration we will find the minimum element in its first position, that is 15. So the first element is sorted. Now in the second iteration we will start with the output of the first iteration, that is 15, 16, 40, 34 and 15. Now we will set 16 as the minimum element. Now we are going to compare 16 with 40. Fine, 16 is less than 40, so we will not change. Now 16 with 34. Fine, 16 is less than 34, it will remain same. Now 16 with 15, we know that, sorry, it is 17. 16 is 17, so that means it will remain same. So 16 is the next minimum element, so it will remain same. Now in the third iteration, so the second iteration, it will be 15, 16, 40, 34 and it is 17. It is 17. Now in the third iteration, we are going to set 15, 16, 40, 34 and 17. So the next minimum element is now 40. Now we are going to compare 40 with 34. We know that 40 is greater than 34, so 34 is the next minimum element. Now we are going to compare 34 with 17, and we know that 34 is greater than 17, so 17 is the next minimum element. So simply we are going to interchange 17 and 40. That means 15, 16, 17, 34 and 40. Now up to 15, 16, 17, these three elements are in sorted orders. They have reached their position. Now in the fourth iteration, 15, 16, 17, 34 and 40. Now 34 is the next minimum element that we are going to set in fourth iteration. So we know that 34 is less than 40. So we know that 34 is its position. It is set in its position. That means the list is sorted. 15, 16, 17, 34 and 40. So the list is sorted here. With the help of selection sort, in the fourth iteration, we have sorted the list in the ascending order. The next topic is insertion sort. Insertion sort is one of the simplest sorting algorithms for the reason that it sorts a single element at a particular instance. It is an intuitive sorting technique. It is not the best sorting algorithm in terms of performance, but it is slightly more efficient than selection sort and bubble sort in practical scenarios. This sorting algorithm works similar to the sorting of playing cards in hands. This is also efficient for small data sets, and it is also a stable algorithm like selection sort and bubble sort, and it has also the space complexity of order of 1 like the selection sort as well as the bubble sort, and its time complexity, the best case is order of n, the average case is order of n square, and worst case is order of n square. That is similar with bubble sort. Let us understand the working of insertion sort. In the insertion sort, we will start by assuming the very first element of the array is already sorted, and inside the key we will store the second element, and next we will compare our first element with the key such that if the key is found to be smaller than the first element, we will interchange their indexes or place the key at the first index. After doing this, we will notice that the first two elements are sorted. And now we will move on to the third element and compare it with the left hand side elements. And if it is the smallest element, then we will place the third element at the first index. Else if it is greater than the first element and smaller than the second element, then we will interchange its position with the third element and place it after the first element. And after doing this, we will have our first three elements in a sorted manner. And similarly, we will sort the rest of the elements and place them in their correct position. Now let us understand insertion sort with the help of an example. We have taken the same set of elements that we have taken earlier for selection sort and bubble sort, that is 17, 16, 40, 34 and 15. In the first iteration 17, 16, 40, 34 and 15. So we know that in insertion sort, the first element is considered to be already sorted. So the key element is the second element, that is 16. And now we will compare 17 and 16. Now 16 is less than 17 and 17 is greater than 16. So they will swap their positions. That is 16, 17, 40, 34 and 15. Now in the second iteration 16, 17, 40, 34 and 15, the key element is 40 and 40 will be compared with 17. 40 is greater than 17, so no interchange. 40 is greater than 16, so no interchange will take place. So it will remain same. In the third iteration 16, 17, 40, 34 and 15. Now the key element is 34 and 34 is less than 40 and 34 is greater than 70. So 34 will be placed in 17 in place of 40. That means it will swap the position 34 and 40 will be placed in place of 34 and 15. And now in the fourth iteration, the key will be 15. Key is 15 and 16, 17, 34, 40 and 15. And 15 is the key element. 15 will be compared with 40 and it is found that 15 is less than 40. Then it is seen that 15 is less than 34, 15 is less than 17, 15 is less than 16. So it is observed that 15 is the smallest element in the entire array. So 15 will be placed in the first element and the rest of the elements will remain as it is. And hence our array is sorted. The elements are sorted and this is the final sorted list with the help of an insertion sort. Thank you everyone for watching the video till the end. Like, share and subscribe for more videos. Thank you.